Last week we learned how to solve a quadratic formula by factoring, and I don't know if you were wondering what would you do if you couldn't factor. Maybe some of you even remember doing this in grade 10, but if you can't factor, or even if you can and you just are stuck, we can use something called the quadratic formula. So I've written a quadratic formula out right here. So x is equal to negative b plus or minus the square root of b squared minus 4ac, and then all of that is divided by 2a. Now, if you're wondering where the a, the b, and the c come from, all you have to do is look at the formula I gave you below. This is standard form for a quadratic equation. So the a is the number in front of the x squared, the b is the number in front of the x, and the c is the number that's by itself. In the next couple of slides, we're going to be going through a few examples of how to use the quadratic formula. Some examples you may be able to factor, and that could be faster. Some of them you maybe can't factor, and that's okay too. So this quadratic formula works for every single quadratic equation that I give you. So our first example says solve 2x squared minus 5x minus 1 equals 0. So the first thing that we need to do is recognize which of these numbers represent our a, our b, and our c. Now, typically what you could do is you could take a look at this and you could say, can I factor this? So this is decomposition. I'm looking to see if I can find two numbers that multiply to 2 and add to 5. I know that's impossible since the only things that multiply to 2 are 2 and 1. So I'm going to go back now and I'm going to say my a is 2, my b is negative 5. Don't forget to take a look at the signs. And my c is negative 1. Now that I know my A, B, and my C, I can plug it into the formula. So I want to see your formula every single time. The first reason is because that's just a good way of knowing the formula. The second reason is because if you plug in wrong numbers but wrote the right formula, then I could figure out where your mistakes are and I could help you a little bit better and even give you more part marks. So now that I have my formula, I can just start plugging in my information. So the first thing that I need is negative b. So my b is already a negative 5. That means that what I'm plugging in is the opposite of that. So I'm actually plugging in a positive 5. So 5 plus or minus the square root of b squared. So negative 5 squared minus 4 times a, which was 2, and c, which was negative 1. And then all of that is divided by 2 times a, and my a was 2. So I'm going to simplify a little bit more here. I have 5 plus or minus the square root of negative 5 squared is 25. And then I'm going to be doing the second part of this equation. So a minus 4 times 2 times negative 1. 4 times 2 is 8, times negative 1 is negative 8, divided by 4. Now, what I know is that this actually becomes positive 8. So what I have is 5 plus or minus the square root of 25 plus 8 divided by 4, which equals 5 plus or minus the square root of 33 divided by 4. Now, I am going to give you a hint when you're typing this into your calculator. Please make sure that you're using the equals or the enter button before you do the division. So I'm going to verbally say what you need to be typing in. So we're going to get two answers, and we're going to get two answers because we're doing this equation once with a plus and then again with a minus. So I'm going to do the plus first. So I'm going to be typing in 5 plus the square root of 33. Here's where you need to hit equals or enter before you hit divided by 4, or you will get a wrong answer. So the first answer that I'm going to get is 2.69. Now the next time I'm doing this, I'm going to be doing 5 minus the square root of 33. Again, hit enter or equals and then divided by 4, and I will get negative 0.19. That means, or what these solutions mean, I'm going to have a graph. I know it's a parabola because the equation is 2x squared minus 5x minus 1. And I know that this parabola is going to cross my x-axis at 2.69 and a negative 0.19. So those are my two roots, or my two solutions. The next example that we're going to be doing is solving x squared minus 30x plus 225. So for this example, we can factor it. So if you did want to go ahead and factor that, you could do that and you would be able to get an answer a lot quicker. Just because I want to show you how the quadratic formula works and prove to you that you can use it for any equation, I am going to be going ahead and using the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Now I'm going to go ahead and I'm just going to be lazy and I'm going to say that I know that my a, my b, and my c are here. Okay, so my a is 1, my b is negative 30, and my c is 225. Now be careful, especially with the a is 1. We know that there's an imaginary 1 there, so don't put 0 if there is an x there that can be included. I'm going to go ahead and I'm going to plug these numbers in. So negative b, again, my b is negative 30, so I do need to put positive 30 here. We always switch the sign. B squared, so negative 30 squared, minus 4 times a, which is 1, times c, which is 225, divided by 2 times 1. So I have 30 plus or minus the square root of negative 30 squared is 900. 4 times 1 times 225 is 900. Divided by 2 times 1, which is 2. So I'm going to simplify even further. 30 plus or minus the square root of 900 minus 900 is 0. And the square root of 0 is 0. So I'm going to get two answers again. I'm going to get 30 plus 0, hit your equals, divided by 2. And I'm going to get 30 minus my 0, hit equals, divided by 2. So what I'm noticing is that both of these answers are the exact same, and I didn't actually even need to write one out the second time, okay? So when I'm looking at this particular example, I'm only going to get one solution. So if I'm drawing my grid, I have a parabola, and I know that it only crosses the x-axis one time at 15. In this equation, it is combining a couple of different things. So just like we did last week, we need to be rearranging the equation to make sure that it equals 0 before we go ahead and either try and factor or use the quadratic formula. We have a couple of options here. I could take the 2x squared and move it over to the right-hand side, or I could take the 1 plus 5x and move that to the left-hand side. I am going to go ahead and just take the 1 plus 5x and move it to the left with the 2x squared. So I'm going to be getting 2x squared, and I'm going to rearrange it just in order. So I'm going to move the plus 5x over first to get a minus 5x, and then I'll move the 1 over to get a minus 1 equals 0. Now, this tells me right away that my a is 2, my b is negative 5, and my c is negative 1. I can go ahead and I can plug that into the quadratic formula, which of course you know by now I want you to be writing out every single time. So x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. X is equal to, again, my b is negative, so a positive 5 plus or minus the square root of negative 5 squared minus 4 times 2 times negative 1 divided by 2 times 2. X is equal to 5 plus or minus the square root of negative 5 squared is 25, and then minus 4 times 2 is 8 times negative 1 is negative 8. And then all of that is going to be divided by 4. So x is equal to 5 plus or minus the square root of, now again, we have a minus negative 8, so that's really going to be a plus. So 25 plus 8 divided by 4. X is equal to 5 plus or minus the square root of 33 divided by 4. I know that I'm going to be getting two answers. I'm going to be doing my plus first. So 5 plus the square root of 33, hit equals divided by 4, and I'm going to get 2.69. And then I'm going to be doing 5 minus the square root of 33, hit equals divided by 4, and I'm going to get a negative 0.19. So again, if you're thinking about it in terms of your graph, you have one root at 2.69 and one root at negative 0.19. Now, if this question looked familiar to you, it's because it was. So this was actually the exact same example as example 1. The only difference was that in example 1, I gave you everything set equal to 0 already, and in this example, you had to rearrange the equation to have it equal 0 before you could start solving. For this example, I'm going to go ahead and do the exact same steps. So a is equal to, I guess in my example I should have included all of the equation. A is equal to 3, B is equal to 2, and C is equal to 15. I'm going to go ahead and I'm going to write my equation, or my formula, negative b plus or minus square root of b squared minus 4ac over 2a. Negative b, so b is 2, so here I have to write negative 2 plus or minus the square root of 2 squared minus 4 times 3 times 15 divided by 2 times 3. So negative 2 plus or minus the square root of 2 squared is 4 minus 4 times 3 times 15 is 180 divided by 6. So negative 2 plus or minus the square root of negative 176 divided by 6. Now, here's where we would normally get our two answers. We would do negative 2 plus the square root of negative 176, hit equals divided by 6, and right away we would get an error, okay? So doing the square root of a negative number is not allowed. This means that we cannot go any further, and we just have to write, therefore, there are no real roots. We've done a few examples today, so you'll see we've done an example where there were 2 roots, where there were 1 root, and this example where there are no roots. I will explain a little bit more in the next lesson about what that means and what those graphs look like. So for now, all you need to know is that when you do a question where you get a negative underneath the square root, you're just done and you can't go any further.